In the world of programming, there's always been this epic tug of war. It's this fundamental choice every single developer has to make. And it's a choice that really defines projects, careers, and the very tools we build. And that choice really boils down to this. Do you want code that's easy and expressive to write? Or do you want code that runs with just blistering metal-to-the-metal speed? For decades, the answer has always been, nope, you can't really have both. You gotta choose.
So on one side, you've got your productivity champions. Think Python, JavaScript. They let you build amazing things super quickly, but there's usually a performance cost. And then on the other side, you've got the performance kings, C and C+. I mean, they give you that raw power, but they demand that you manage every single detail by hand, which often comes at the cost of safety and simplicity.
But what if you didn't have to choose? What if a language came along and made this, well, almost impossible promise? The productivity of a high-level language with the performance of a low-level one. This brings us right to the heart of Rust, the idea of the zero-cost abstraction.
Okay, so let's really dive into what this means. A zero-cost abstraction is actually a pretty simple but totally revolutionary concept. It means you can use all those nice, high-level features you love, things like iterators and closures. And the final, compiled program, it runs just as fast as if you had painstakingly written out all of the low-level instructions yourself by hand.
And this whole idea is built on one incredibly powerful mantra that is at the very heart of Rust's design. Let this one sink in. What you don't use, you don't pay for, and what you do use, you couldn't hand code better. See, this isn't just some nice-to-have goal, it's a core design constraint. All right, that sounds amazing in theory, right? But talk is cheap. How does Rust actually pull this off? Let's look at the proof right there in the code and see how this abstract idea becomes incredibly concrete. Okay, so take a look here. On the left, you see this really elegant, expressive line of Rust using an iterator. It's clean, it's easy to read, right? And then on the right, you see the low-level equivalent, a standard for loop, the kind of thing you'd write in C or C++. So, which one is faster, the fancy high-level one or the old-school manual loop? Well, here is the absolute magic of it all. At compile time, they become the exact same thing. The Rust compiler is just so smart that it takes that beautiful, abstract code and boils it down into the exact same hyper-efficient machine code as the manual loop. No hidden costs, no overhead, zero. So how on earth is this even possible? I mean, it feels like it breaks all the rules, but it's not magic. It's a series of incredibly clever engineering decisions that happen inside the Rust compiler. So let's peek behind the curtain a little bit. Rust uses a few key tricks at compile time, and that's the important part, at compile time, not at runtime. First up is monomorphization, which basically turns generic code into specific concrete versions. Then you've got inlining, where the compiler just copy-pastes small function calls to get rid of overhead. Third, and this is a big one, Rust has no garbage collector, so no unpredictable pauses. And finally, all those critical safety checks, they're done when you compile, not while your program is running and slowing things down. So, okay, those are the technical details. But what does all this actually add up to? Let's take a look at how these compile time tricks give Rust a truly unique advantage in the whole landscape of programming languages. This right here, this is the sweet spot Rust carves out for itself. It gives you the raw, uncompromised speed of C and C++. I mean, the kind of power that gets you right down to the bare metal. But it pairs that with the clean, expressive syntax of a higher-level language. And on top of all of that, it gives you memory safety that's enforced by the compiler, protecting you from whole classes of bugs. It's kind of the best of all worlds. And this table really drives the point home. Just look at the zero-cost abstractions row. Rust and C++ are the big players here. But then look down at the safety row. Rust offers that high safety at compile time, while C++ is, well, famously low. And languages like Java, they get safety, yeah, but through runtime overhead. Rust is really the only one here that gets a green check in pretty much every box for high-performance systems. But the benefit of this design goes way beyond just benchmarks and feature lists. There's a deeper, more profound advantage here that affects how we as developers think, how we read, and how we write code. It's what you might call the power of honest code. And this isn't just some theoretical point. A developer from one of the sources put it perfectly, saying, the source code clearly expresses what it actually does. There is no hidden magic or tricks. Wow, that's a really powerful statement. So here's the crucial point. With Rust, what you see is almost exactly what you get.
The code you're reading is a very, very close map to what the machine is actually going to execute. In contrast, so many other languages have all this hidden machinery running behind the scenes. A garbage collector, a just-in-time compiler, an interpreter, all of which makes it way harder to reason about what's really happening under the hood.
And that very transparency makes reading Rust code an absolutely incredible educational experience. Because there aren't any magic layers, you're not just learning an API. You're learning how systems actually work. The data structures you see, they correspond to real memory layouts. Those concurrency patterns, they correspond to actual threads and state machines. It's the real deal. To put it as clearly as possible, Rust's zero-cost abstractions don't just make the code fast, they make the source code truthful. It describes not only the logic of your program, but also its cost. Which leads us to our final thought. The true power of Rust's philosophy isn't just about winning some performance race. By peeling back all those layers of magic, it gives developers a much clearer view of what their code is actually doing. So you see, Rust isn't just fast, it's educational. And that might just be its most powerful feature of all.